Does anyone here have kids? You have kids? Anyone got kids? Yeah? So what do you do when they don't go to bed? Yeah, well, you can do that. Okay, or you can do what I do. The monsters will get you. And then they're all like, no, monsters don't exist. Mummy said so. And you say, they do exist. I've seen them. Following continuous integration best practices at work. So let's just define what our terms are here. So I'm just assuming that you all know about what a build is. What I'm calling a build is that automatic thing that turns source code into working software, or what should be working software. It's not everything that you need to do in order to ship it to customers. Maybe you've got QA, maybe you've got documentation, something like that. But it's that automatic bit, and if you're following continuous integration, then it's something that you want to do on every change to your software. So what's a monster build? That's builds. Well, just as this little pink van is to a monster truck, a normal build is to a monster build. I'm down in the bottom right quadrant here. That's where you are with me. We're talking about monster builds. We're not talking about those simple projects where you have a little library and it takes you, 10 seconds to run all of the unit tests that you've been able to come up with. And because really that's easy. Well, everyone knows how to do that. That's 2 thumbs up. That's no worries, mate. Down here in monster build land, the rules are all different. And I just want to pay tribute to this awesome American invention, the monster truck. This is one of my favorites. So what is the monster build threat? Well, while you're focusing rightly on shipping software and then realizing that when little problems pop up, you need to make sure you... What was that? You need to make sure that you work on the testing. You've got to automate this testing, because otherwise you're going to have someone come and check that this problem you just had doesn't happen again. So you add some more tests. You add unit testing to check single units of work are working. Then you find more problems pop up, and then you realize that you need to test things in combination. You work out that you need integration tests. So you combine multiple parts of the software together and you test that they work with each other. You also find you need functional tests. If you keep going and your software is successful and you have that luxury problem of having a lot of customers or a lot of users, then you also might find you need to drive a real web browser. If you're writing a web app, anyone doing web apps here? Yeah, a few. It's all gone iPad now, has it? So anyway, you need to drive the real web browser in order to check that a real web browser will work. And if you don't do that testing, then it'll be a customer who finds that problem. But problems keep dropping in, and you need to make sure that you do all of this testing and you're focusing on shipping. And maybe if you work at one of those companies where you've got to do this other stuff as well, you'd be not just writing the code and testing the software, you're doing all this sort of other stuff. And what happens is you end up with something like this. Well, we did. Now, what the hell is that? What is that? That is a monstrosity. That is a Jira dashboard, a Bamboo dashboard at Atlassian. And if you see the zoomed in view there, see how many plans we've got? Now, you must be thinking, your faces all just went like this, because I just told you that that's just for Jira. That's not the whole of Atlassian. That's not for Bamboo or for any of our hosted products. That's just for Jira. Okay? So I call that a monster problem. And how do you solve it? Well, just to put it in context, I wanted to show you that it's not just a problem of that scale. Among our other Bamboo builds, the one in the middle there is for multiple products. We've got a Poland team working on some builds that are specific to them, and we have hosted team out on the right-hand side. And we've got plugins as well. Jira comes with bundled plugins. Some of those are on this other server. But the problem is actually getting worse, because when I took this Jira screenshot, this Jira Bamboo dashboard screenshot when I started preparing this talk, and during the preparation for the talk, it got bigger. Okay? Monster problem. This is not just like some little library where the theory of running all the tests on every check-in and having a plan for your Selenium tests and a plan for your functional tests, and it's all just going to work out fine. No, you get some serious problems. So our solution at Atlassian was to, in some way, summarize all of these multiple builds into a digestible form. And you probably saw this in the keynote. This is actually now becoming this is an early version of the Wallboards plugin for Jira. And you can see on the right-hand side, we've got summary information for multiple builds. So we don't want to see all of those builds all of the time. Sometimes we want to take multiple builds and then roll them up into a summary information. We actually have some other tools that we haven't released yet as products. Some of them are just simple things like grease monkey scripts that run on top of Bamboo, and if this build and this build and this build are all green, then just roll them up into one little summary that says everything's green under there. So that is too many builds, but there's another dimension in which build monsters can come and get you. On the Jira project, again, this is the project I work on, so most of my examples are from that. Our release build, so that is the construction, the compilation, packaging, the unit tests, the functional tests, and everything that needs to be done in order to have a candidate release took between 30 and 60 CPU hours to execute, which actually translated to 30 to 60 wall clock hours, because we have a machine that's running these tests end to end. You can't run multiple tests on the same server at the same time because one test will trip over the other one and you'll get dodgy results. And so that was okay when we used to be able to call it the nightly, but at 60 hours long, you can't call it a nightly anymore. So that was a big problem. And part of the reason why we had that problem was because we supported so many different platforms. And what I mean by platforms, in our case, application servers, versions of Java, different versions of the JDK, different databases, different web browsers, different operating systems. And for each one of those combinations, we had about 3.5 hours of functional test time. So that was the bulk of it. We did run other tests, but that was really where most of the time was being used. So it's 3.5 hours times each of these combinations. And we didn't want any of these combinations to have a problem that would only be found on a customer site. We wanted to discover the problems before we ship the software and fix them before we ship the software. So what is the problem with long builds? It's not just that you can't call it a nightly anymore. There is a real concrete problem here, and that is that basically long builds cause low development velocity. And how does that happen? How does a long build really slow you down? It might be obvious to some of you, but there are a number of factors involved. One is that if you have a long build, let's say it's a 3.5 hour functional test run, that's 3.5 hours time, and that's the soonest time you can find out whether or not that change you just committed to the software has broken something unrelated. So you're not going to sit around for 3.5 hours doing nothing while you wait for the results. You're going to be moving on with some other work. And then you find out, and the whole team finds out, that the build is broken and it was you. And so then you need to stop doing what you're doing and go and fix that problem. Commit the change and wait 3.5 hours to find out whether you fixed it. Presumably you run the specific tests that broke, but basically it's a real problem when you're context switching because you've broken your concentration. I don't know if any of you have heard of the mental state called flow. It's something that some programmers often talk about, things where you get into the zone. You know, you're coding and everything starts to work. You know what the task is, you know what the current state is, you're moving through effectively, and if someone interrupts you, it loses all of that context. It's like juggling or something like that. And you can waste 15 minutes from just a simple interruption. So the more of those interruptions that occur, the slower you're going to be developing. It also hurts with task entanglement, which is a separate problem, but it's related, and that is that you have to have multiple tasks running in your head at the same time because you've got to have that build that bug that you just committed a fix to, and whose build is in the pipe, in your head. There's something there always ticking over going, I hope that worked. And then what you're working on now. You're always going to be juggling those multiple tasks. Another problem is that when the build breaks, there can be more confusion about who broke it. Because within a 3.5-hour period, maybe 3 people have committed. And then we find out the build was broken due to someone's check-in 3.5 hours ago. So then everyone goes around saying, who broke the build? Oh, I don't think it was me. I only tried. That would never have broken the build. I just committed this one little fix. I'm going home. You know. So that confusion also wastes time. And the whole thing is not agile at all. I mean, agile is supposed to be a way of fast feedback. That's pretty much all it is. Agile is about fast feedback. Long builds are slow feedback. So bad. Now, we were having this on the Jira team. I've got to tell you, monsters were on the attack. We were really having trouble with this. And so we were all talking about it. How do we tame these monster build times? And we came up with essentially a little shopping list of things we would do. It's the same old stuff. Optimization. We also looked at what I'm calling here matrix culling. It's just the combination of platforms that you support. I'm going to go through these in a bit more detail in a minute. And also maximizing what I'm calling test power. I'll explain that in a minute as well. And minimizing the time you have to wait for a test to complete. So just cutting it down into these 4 different dimensions. But the first thing with optimization is you must measure first. You cannot start optimizing. I know you think you know what's slowing you down and what's the slow part of your build, like I always used to, but it's taken me a long time, and now I recognize that I don't know what is slowing the build down. I don't know what's slowing the software down. I'm going to measure it and get the computer to tell me what's slowing it down. So Clover team member Nick Pello put this awesome little instrumentation into the Ant build tool. I'm not sure if any of you use Ant, but it's pretty popular in the Java world. And it's really like Make, if you've used Make. And it instruments the time of the measures of duration of each task in the build. And Nick was quite surprised to discover actually most of the time in his build was being spent zipping up files and unzipping them. And if you're just trying to test the software, why do you care about zipping? Actually, what he did was he just turned off compression on the zipping and unzipping, and that took out most of the time of the zipping, unzipping task, and he got a massive speed up because he measured it first. So with optimization, measure first. Another couple of things that you can focus on when you see your time being spent in resolving artifacts across a network, maybe downloading the internet if you're using Maven, checking out your source code. You can reduce the amount of network and disk operations you do in your build, just as you do in your software, and that will speed things up. So you can have maybe repository proxies for resolving artifacts. You can co-locate your servers. You can maybe use RAM disks. We've done some tests on RAM disks, and for local disk intensive operations, it can speed it up. Another thing you can do is cut rework. I mean, if you find that your build, just because it's easier to specify, says zip this up, copy it here, and then go find the thing that's over here and unzip it and process it further, or it's a component of your build, you can actually go in there and say, well, actually, in this case, we don't need to zip it and unzip it and copy it back. We can just skip all of that and copy it directly, say. So it will really depend on your situation, but looking for rework you can cut out is it's a technique you can use to speed up your build. And of course, at the end, you need to measure again, because likely you've just introduced complexity into your build, and you want to make sure that that's justified in terms of an actual speed increase and not just fingers crossed. So this is an example from the Jira functional tests of where we cut rework. And what I noticed when I profiled the functional tests running on Jira was that there was a lot of time being spent. Our functional tests are a web client that connects to the web application and then performs operations, and so there's a lot of HTTP round trips network channel. And we have a functional test framework which has operations in it to manipulate Jira, to set up this notification scheme or add the permissions or import a project or do things like that. And every time it needs to do any of these admin things, it needs to go to the admin screen or make sure that it's on the admin screen in order to click that link to set up that project, to set up that notification scheme or whatever it is. So I made a change to the go to admin function and just made it check if it was already on the admin screen. And if it was, just do nothing. And this sped up our functional test by 20%. So, I mean, that was a really quick thing to do. It required the measurement to really see that maybe I could change that. And we got quite a decent benefit from it. Of course, since we've used that all up. The other thing you can do, I mentioned earlier, was culling the matrix. The matrix, you can be told what the matrix is, despite being told otherwise. No, it's really just the supported platforms, the combination of the things that you support. And some of you might be thinking, I don't know how, I support one platform. I've software as a service, my customers all used to use that one thing. And maybe you want to think about how many browsers they're using. Maybe you really do have one, in which case you can't make any ground here. But a lot of people support multiple browsers, and there are more and more browsers being created, it seems like. There's now Chrome, and the Safari's getting pretty big. So you have to test on these multiple browsers. But maybe you really want to look hard at which ones you do support, because that can reduce the amount of testing that you have to do. Same with databases, what versions of the libraries you're using. So you're removing the amount of work you have to do in your build. So in Jira, we had a number of events that occurred. We dropped support for Java 1.4. There were some app servers that came from the dawn of time that we actually said, okay, we're sorry, but we're not going to test on those anymore. They might work, but we don't support them. We also had a change to our licensing, which this wasn't why we did it, but we had multiple editions of Jira which had different functionality and therefore different testing, and each had to be independently tested. But when we moved to user-based licensing, it really just meant we only had one code base to test. And so that reduced the amount of work. And we got our release from that horrible number before down to about 18 hours. So we could call it a nightly again. And so now the next topic I want to really talk about, and what you can do to reduce the runtime speed, the duration of your build, is what I'm calling power to weight ratio. Forgive me for being a bit cute with this, because it really helped me remember it. And that there is a notion I think of as test power. Each test has the ability to detect the presence or absence of bugs. And it's the degree to which a test can do that for bugs that no other test can do, that is its power. So unit tests have quite good power at discovering and detecting the presence and absence of bugs in the small, but there are certain categories of bugs that they just can't detect. So you might have your unit tests, which you don't have to wait very long for, and at the same time also have functional tests, which, while they test things that unit tests can't test, you will have to wait longer for them. So you can use this ratio. It's just a notion. It's not a number. You can just use this ratio to say, look, I think maybe we really we need these Selenium tests, but we're only going to run them once we're sure that the functional tests have completed, say. So you can be selectively continuous. You want to be continuous, you want to do continuous integration, so you're going to run your unit tests on every check-in, but maybe only when the unit tests pass will you run the functional tests, perhaps. So you can use this power to weight ratio to decide when and how you run the tests. And there are a number of different ways that you could split this up. You could look at multiple branches you're running. You can maybe run a test only nightly, or even only Sundays. So if you want to support Opera on AIX on Amiga, then you can run that on Sunday and find out. You can take the risk. Maybe we won't find out for a week that we've just broken that. So what I came to was a realization that after having done all this work to cut the functional test runtime down and the release build runtime down, we kept on adding more tests. We kept on adding more features. We supported, in some cases, we supported more platforms. New versions were coming out. We had to support that. We still got IE6 and multiple browsers, multiple versions of each of those. And with modern web applications, which involve a lot of tricky AJAX and nice front ends. They're really much more complicated to test and more time consuming because they require a full browser to be there. So the lesson here was that these monsters in our builds, they were of our own making. So we really had to stop being defensive and just reducing the amount of time they took. It was really time to go on the attack. And St. George, who knows St. George? He's a dragon slayer. He didn't just sit back and cull his matrix and optimize his builds. He's a dragon slayer. He goes out there and look at that. Well, it's a bit small actually, that dragon. got a mean bite. So what could we do next? Well, just going to take a left-hand turn for a minute. This is a little bit of history. You probably all heard of Moore's law, but for those of you who haven't heard of it, it's basically that ever since the World War II, the speed of computers has become greater and greater and greater. This is actually a logarithmic graph. So when you see a straight line, that means if you had a linear graph, it would actually be curving up. So you can see what is a continual trend of, in the blue, the clock speed of CPUs rising and rising and rising. And in the green, the transistor density rising and rising and rising, except up until about, 2005, when clock speed stopped rising. So this is where we live, in this red zone here, a point in history where we don't get faster clocks anymore. So back in St. George's day, you could just buy a bigger build box and you'd be able to just get faster functional test runs, or you'd have less of a monster problem in your builds. But that party's over. So this is the guy, Gordon Moore from Intel, and got a few words to say to him actually. So Gordon, what's with the clock speed? I thought you said we could always get more. And I can just imagine him saying back to me, look, hey, don't blame me. I just said you could have more transistors. And we can get more transistors, but of course, what that means is we're getting multiple cores, we're getting more and more of these compute resources, but they're not, in themselves, they're not any faster. And that made me think of Gene Armdale. And I can imagine him there in this tastefully appointed office saying, you know what you've got there? It's called an embarrassingly parallel problem. Embarrassingly parallel problem. An embarrassingly parallel problem is what computer architects like Gene Armdale dream about. It's just begging for a very large number of computers to be given to you to solve a problem. So the solution I thought about this for a long time, and I really wanted an elegant solution to running multiple tests at once. But the problem I kept tripping over was I needed to try and make sure that there was coherence to the single build. We say this is our functional test run. We want to have all of that stuff just look like one test run, but actually run on multiple computers at once or multiple cores at once. And I only made any progress on this once I just threw that assumption out. So this is what was happening. We had a timeline where there was a checkout and compile in yellow happening. That took a certain amount of time. And it was running on one build agent, or our build server. And then there was a lot of testing. And we needed to move to something more like this, where you have multiple agents. Each one would check out and compile, and then run some of those tests. And what happens is you get the embarrassingly parallel problem versus the elastic batches of bamboo. This is the situation we had. I could just imagine like a sci-fi novel, or maybe a wrestling SmackDown match or something like that. And we ended up with, this is a chunk of recent Bamboo dashboard, we ended up with the functional test for Jira by having 15 plans. And as you can see, the top one there, I don't know if you can read that. I didn't assume you could read it, but the top one's basically running further 3 hours, 3 and a bit hours. And that runs all of the tests end to end. But each of these builds here, all triggered at the same time, they will run and they take, most of them are in the 20s, 23 minutes, 24 minutes, 22 minutes. There's a long one there, 37. They're not all exactly the same length. But that's a big improvement. That means that we get our result of, did I break the code, at worst in 37 minutes. And having just come from 3.5 hours, this was huge for us. So it wasn't the elegant solution I wanted to do, but it works. And this is how you do it. We needed to give 2 parameters to our build, which was, it's actually Maven 1, but it doesn't matter, it can be anything. You give it 2 numbers. One is, how many batches do you want to have? In our case, we got up to 15, that's our current step. And then for each of the plans that runs that script, you need to tell that script what the current batch number is. So 1 is 1, 2, 3, up to 15. And then inside the test runner, in our case, we have a functional test suite class. We can just implement this logic here. You use those 2 numbers to select that slice. And this worked pretty well. You can see we used global variables in Bamboo. So we set the maximum number of batches just at the top there to 15. We actually have other batches, and they keep growing and growing, and this is part of the problem I was showing you. But there's a Jira crowd integration build there, and there's another one. And they run different numbers of batches. But those numbers, that 15, we can change that just in one place, and then it'll all automatically run in 16 plans. And we'd get a performance boost. We'd get a speed, a duration drop. So we take these. This is our builder configuration in Bamboo. I mean, this is not a product pitch. You don't have to use Bamboo to get this. You can get this in other build tools. You can get this using a shell script. So you pass those 2 parameters. This is the hard-coded batch number 1's config, and it's the bamboo.jira.batch.max variable. So this is the global variable that Bamboo will pass to the script. And then the only thing you need is lots of computers. So if only you had just a button you could push, say, and it would just give you lots of computers, right? That sound pretty cool? Yeah, well, you got that because actually with Amazon Web Services, you can requisition virtual machines just through an API. And so what we added to Bamboo was what we called Elastic Bamboo, basically elastic agents. They're using a virtual machine running in the cloud to execute functional tests. And this solved the problem pretty well. Once we got a couple of stability issues worked out, we learned how to run any number. Well, I mean, obviously there are some limits, but 20, 50, how many virtual machines you can afford, and then you pay them by the hour. And so you can get all this through the Bamboo administration interface. And the point of that for me was I wanted to give management a dial, like a volume knob, where they could just decide how much money they wanted to spend on physical infrastructure, or virtual infrastructure in this case, and get an improvement in development velocity. Because the build duration has an interaction with the speed of development, which I talked about earlier, the more agents you have, the faster you can develop. So this volume knob then was in the hands of management. They could choose the level of investment they wanted to make. But it doesn't go on forever. As you saw, there's a checkout happening and a compile happening at the beginning of the functional test run. You have to do that for each agent. So it doesn't matter how many agents you run, you've always got that portion. And this is, in fact, Armdale's law, where he says that he describes it's like a law of diminishing returns, certainly after some point. You can see in the beginning of the graph, it's actually a law of increasing returns. Down the bottom, we have the number of processes. And on the left, we have the speed up, where for each of these colored lines, you have a different proportion of the total workload that can be run in parallel. And that ratio there, that percentage, you'd get that from the percentage of work that you have to do up front per build versus the actual just functional tests that particular plan will run. So in our case, the percentage was really, really high. We spent very little time checking out and compiling and very long time running functional tests. So our knob was way down on low volume, and we had a long way to go. But there's only so much benefit you can derive from that. Once it gets under something like 10 minutes, you're probably not going to be improving your development velocity that much. Anyone can wait, 5-10 minutes and get back in what they were doing. But at least it made it a management decision. So now I want to talk about something really scary. So reliability. I love these, don't you? Pixar. So reliability. The next problem I was aware of in terms of the monstrousness of our builds was that we relied on so much infrastructure to get one build out the door, one complete release test, that when I looked at it and added it up, there were so many things that could break it, and did. So this is just an example for Jira, what it depended on. So we have a test database, we need the internet. I'm pretty sure we need the internet. I haven't tried turning that off, but whenever it goes down, things just don't work. So I'm just assuming we need that. We have the actual build agent that runs the release build. There's some shared drives. We need Subversion. We need Maven 2 repository and a Maven 1 repo because we're still in Maven 1 using in Jira. We needed a license server for the installer builder. We needed Bamboo. That had to be up. If anyone turned these things off, our release would fail. And when that was about 60 hours long, you need to keep all of these things running perfectly for 60 hours, or you've got to start again. And of course, we relied on Java blogs, right? As you do, javablogs.com. If javablogs.com went down, so did our build. Why was that? Well, it just so happened we discovered this once when it wasn't up, and it was actually that there was some little HTTP utility that used javablogs.com as a sample URL, and when that wasn't there, the test failed. So you guys didn't get a new version of Jira. But we did fix that. But the lesson here is that the dependency on all of these unreliable parts gives you false negatives. It gives you a broken build that is not the result of a developer's mistake, yet it takes their time to find that fact out. So we came up with this idea from a canary in the coal mine. This is actually some of the excellent work that Jim Severino did. And if you'd caught his talk just before this, he actually built some build and infrastructure dashboards in Confluence. You can use any tools again, but this is what we had. These are what we call the canary builds or the control builds. And these are builds that you create from a known good working version of your software, something that passes all the tests, like 1.0, or probably not a good example, but something that passes all of your automated tests. And you just run that over and over and over, and it should always be green, except if JavaBlogs is down or something like that. So if any of your infrastructure breaks, then you're going to get a failure of that build. So the work that Jim did was, he said, yeah, let's just put this up in a big dashboard, and then the infrastructure team can be watching that, and when they see it go red, that's like the canary dying in the mine, and the miners are all alerted to the presence of these noxious gases, and they get out. So that's, we just ran away when this thing went red. No, what it means is that, yeah, something's down, and we can really start to measure the reliability. So you can, something's up with that top one there. This is a real screenshot. I didn't edit anything out. That really is red for that 7 days or whatever it is. But it really tells us something. And this build dashboard, I just want to show you a little bit more. I didn't see Jim's talk, but he puts this stuff together. It's awesome. So this also shows us things like the time to do a checkout on Jira trunk, and so Confluence commits. You've got Jira commits there. There's a few more things. Average build times across multiple projects. And you see a big spike on this graph, and you know there's something wrong. Like somebody tripped over a cable or whatever. And there it is in situ. There's a slightly newer layout of it. So we have this screen right there sitting with the infrastructure team, and they can see these things go wrong in front of their eyes and then react accordingly. So there's one last thing I want to talk about that gets monstrous, and that's tools. So you may not have this particular battle going on in your team, but you know, there's always something. You know, whether it's tabs versus spaces or you know, Emacs versus Vi or whatever it is, there's going to be something where you're spending a lot of time arguing about the relative benefits of tools, and often the problem is because those tools solve problems in such a completely different way that you really can't compare the strengths and weaknesses of them. And about the only thing I want to say about that is just don't waste too much time on that. It really is an area that can get out of control, but you have to be aware that, say, if you choose Bash, it means that if you want to do distributed builds, you're going to have a lot of work to do. Because Maven, Bamboo, these tools that we use, they solve that problem, and Bash doesn't. Bash might be great when you're starting because you don't have to worry about, oh, this complicated, we just need something simple. Yeah, but look ahead. So they're just some of the lessons for tools. Sorry. So don't want to get into this situation here. So just summarizing now, the monster counter tactics, you want to measure, optimize, then measure again. You want to use the power to weight ratio of tests to decide when you're going to test and what you're going to test. You can use the parallelization and use elastic bamboo. And canary builds will measure reliability for you. And be careful when you're evaluating tools. And one last thing is that the modus operandi of this is you can't just go to sleep now once you've done that stuff. Eternal vigilance. That's the only way you can be clear of this. Thanks. I'll take some questions now.
Thank you, Chris. Great talk. So we got about 5 minutes for some questions, if you got any.
Those ant metrics that Nick made, are those available somewhere?
I knew you were going to say that. Yeah, probably. We have a programming competition every now and then. He just whipped that up in a day. And what I showed you was just straight off his machine. It's not something that's really in a product state, but I'm pretty sure we'd be able to share things like that. So yeah, just get back to me. I'll put you in contact with Nick.
I missed it if you said it. All those metrics about what parts of your build took how much time, was that something Clover does, or is that something custom, or how did you do that?
No, I mentioned Clover because Nick, who did it, works on Clover. It actually is something he added to Ant. But I think you could, I'm not aware of tools that specifically instrument like that, but
Chris,
probably are.
If I can interject, I just want to say that Nick and I have been working on 20% time on fleshing it out, adding Maven support to it. So it is something that ongoing work is happening. We haven't released it publicly yet just because it barely works, basically. We haven't spent a lot of time on it yet, but we're going to continue to refine it and just watch our developer blog, because I'm sure we'll push an announcement when it's suitable for public consumption.
Yeah, that's right. Actually, Tim did work at the same FedEx Day, our programming comp.
Yeah, just a point. If you guys aren't aware of our blogs, we have 6 different blogs that we're running at blogs.atlassian.com, one of which is the developer blog. So all these guys and most of the presenters that you saw in this entire room throughout the last 2 days, they all frequently share good stuff there. So if you're not already following it, I encourage you to do so. Yeah.
Yeah.
Seriously. Let me get through over here.
Well, just a point to looking at the builds. I use Excel. It works, with the Maven log files, and you just run you add an extra column, and it just checks the time between the two, and then sort it, and you'll see one step takes 30 minutes or something.
Yeah, that's a great idea, and you can probably aggregate it in Excel as well.
So I had a question. So my question was, when you have those 15 different builds, then you have 15 different versions of or 15 instances of the source code as well?
No, just one.
No, but on the Bamboo server.
Yes. So each agent, there may be multiple agents on one server, but because we're doing it in elastic agents, they were just one per agent. So, but they all independently check out the code and build it, and then run their portion of those full tests.
So it uses a lot of space, right?
Yeah, actually, this is something I should say. This is not the most efficient way of, in terms of CPU time, of getting build results. But we weren't trying to make it the most efficient way. We're not out for saving computer time. That stuff's really cheap. We're going to save people time. So yeah, we were prepared to be very wasteful with computer resources in terms of that just efficiency number. Check out 15 times, yeah.
I forgot what you called it when you had basically your test cases. Do you add one test case per browser platform? I mean, so if you're working on something, you're going to add 3 or 4 cases for IE, Firefox, Chrome, Safari?
Not test cases, but we want to run the same test on multiple browsers. There might sometimes be something that's specific to browsers, but usually what we're trying to check is that the software works the same, running the same test. So I test that, for example, when I want to look up a user and I click the fancy user browser and start typing characters and it's someone's name in the user database, that it pops up the right suggestions. And then when I down arrow, it actually highlights the right thing, and I push enter, it will complete that for me, and that will be the user that I ended up selecting. So that test runs on the different browsers.
So one test, multiple browsers, or multiple tests, multiple browsers?
Multiple tests, multiple browsers. But
Okay.
each test,
Same function.
multiple browsers, yeah.
Okay.
Yeah, so they run the same test run, but there will be a different, sorry, probably just to make it clear that you make a different build plan, which says, okay, this one's for Firefox. I'm not sure if you saw in the slides, sometimes there's Firefox, Selenium, JDK 1.6, you know, whatever it is. And that will be a plan which is configured to run with that browser, and it will run all those same tests.
Any other questions? Oh, one more.
You said the nightly build takes 18 hours. So what is the continuous integration server build? Is that
Yeah,
like
I didn't make that clear. There are 2 separate kinds of test run we have, and we want one, really. The continuous integration is a number of things will be triggered all at once, and there are all those different kinds of tests I talked about. There's unit tests, functional tests, different browsers, Selenium tests, but they're all triggered on check-in. But when we say, okay, we're done, freeze, nobody check in, we're going to tag it, we're going to call that 4.1.2, and now we want to make sure that that particular tag builds and runs all of the tests. So what we have at the moment is a sequential test run. So it will run all of the different tests, it'll use a source. We've got a source release, it'll build from source and check that the functional tests run against that. It runs war distributions and standalone installers and things like that. So it runs all of these different combinations end to end. So that's what takes 18 hours.
Time for one more quick one? No, all good? All right. Thanks, Chris.
Thank you.